We like to think we have a pretty good handle on how reality works. Things are solid, time marches forward in a straight line. But what if I told you that the universe, based on hard physical evidence, plays by a completely different set of rules? Today, we're stepping beyond that simple clockwork universe to see the proof for ourselves. So let me just ask you this. What if the common sense rules that you rely on every single day, what if they're just an illusion? A tiny, simplified slice of a reality that's actually much, much weirder than we can imagine. I mean, look at this. On the left, that's the world we think we live in. It's simple, intuitive. Objects are separate, time is the same for everyone, and the shortest distance between 2 points is a straight line. But on the right, well, that's what physics has actually proven. A universe where space itself is curved, time is totally relative, and yeah, somehow 1 plus 1 can equal 1. We're going to get to how that's even possible, I promise. For centuries, seriously, we saw the universe as this grand, predictable machine, a giant clockwork, right? Governed by simple, intuitive laws. But then, a series of mind-bending experiments just completely blew that picture apart, and what they found underneath, well, it's astonishing. So, where did this whole revolution kick off? Well, it really starts with one guy, Albert Einstein, and his absolutely radical ideas about energy, mass, and the very fabric of space itself. We have all seen this equation. It's probably the most famous equation in history. But what does it actually mean? The best way to think about it is that mass, the actual stuff you're made of, the chair you're sitting in, it isn't some separate thing. It's just an incredibly concentrated knot of pure energy. But how on earth do you prove something that wild? Well, the proof comes from one of the biggest, most ambitious experiments humanity has ever built. The logic is actually pretty straightforward. Step 1, you take 2 absolutely minuscule particles, protons. Step 2, you accelerate them to almost the speed of light. And step 3, you smash them together and just see what happens. And when I say nearly the speed of light, I am not kidding. We're talking 99.9999991% of the cosmic speed limit. At that speed, the kinetic energy, the sheer energy of motion of these tiny, tiny particles becomes absolutely colossal. So what happens when they collide? If protons were just tiny billiard balls, you'd expect to find some shattered bits, right? But that is not what happens. Not at all. Instead, all that incredible energy converts into thousands of brand new particles that didn't exist a moment before. This is E equals mc squared, happening right in front of our eyes. Pure energy becoming real mass. Okay, so energy can become mass. Mind-blowing, but we can kind of wrap our heads around it. But Einstein's next big idea? It was even wilder. He said that big objects, like the sun, don't pull on things with gravity. He said they literally bend and curve the fabric of space and time around them. So the question is, does gravity itself actually bend reality? The test for this was basically a scientific showdown, Newton versus Einstein. In 1919, during a solar eclipse, scientists measured the light from distant stars as it grazed past our sun. Now, Newton's physics predicted it would bend just a little bit. But Einstein's theory of curved space-time predicted a bend that was exactly twice as large. The result? The measurements matched Einstein's math. Perfectly. It was proof. Space itself bends, and light just follows the curve. So Einstein totally rewrote the rules for gravity and for really big things. But at the same time, another revolution was happening, one that challenged everything we knew about the very, very small. So welcome to the quantum world, where the math gets even weirder. This brings us to the legendary double-slit experiment. Okay, the setup is super simple. You fire single particles of light, photons, one by one, at a wall that has 2 little slits in it. Now, logically, each photon has to go through either the left slit or the right one, right? So you'd expect to see 2 simple bands on the detector wall behind it. Makes sense. But that is not what happens. Not even close. Instead of 2 simple bands, you get this complex interference pattern, the kind that can only be made if a wave passes through both slits at once and interferes with itself. So the only way for a single photon to make this pattern is if it went through both slits at the same time. It exists as 2 possibilities, one path plus one path that then resolve into a single outcome when it hits the screen. It's physical proof that on a quantum level, reality just doesn't follow our rules. All right, I know what you're thinking. Curved space, particles in two places at once. It all sounds pretty abstract, like something for a blackboard in a university. But what if I told you that the phone in your pocket relies on these bizarre principles every single second? Let's talk about your GPS. Here's how it works. GPS satellites are orbiting way up high, where Earth's gravity is weaker. According to Einstein's general relativity, this means that for them, time literally ticks faster than it does for us down here on the ground. How much faster? By about 38 microseconds every single day. Now, 38 millionths of a second might sound like nothing. Who cares, right? But for a system that relies on timing signals that travel at the speed of light, it's a total disaster. If the engineers ignored that tiny time difference, your GPS location would be wrong by about 10 kilometers. That's 6 miles every single day. It would be completely useless. I mean, think about that for a second. The software running on every single GPS satellite is constantly using Einstein's equations to correct for the fact that time moves at a different speed up in space. Without the physics of a curved universe, your Google Maps wouldn't work. Uber wouldn't work. This isn't a theory. It's the invisible engineering that our modern world is built on. So what does this all add up to? What's the takeaway? It means we have to let go of our old, comfortable, intuitive ideas about the world. We have to embrace a new physical reality. One that's been proven again and again to be built on these incredible, deeply counterintuitive principles. So let's just recap. The Large Hadron Collider proved that energy forms mass. The 1919 eclipse proved that spacetime is curved and that light follows that curve. The double slit experiment proved a particle can be in multiple places at once. And your phone, right now, is daily, constant proof that time itself is relative. Every one of these ideas shatters our common sense view of the world. And here's the thing. These proofs aren't the end of the story. They're just the beginning. They open the door to even deeper, weirder questions, which kind of leaves us with a choice for what to explore next. Do we dive into how the simple act of looking at a quantum particle fundamentally changes its reality? Or do we get into the crazy mathematics that describe exactly how you'd have to crush matter before it literally collapses space into a black hole? Believe me, the rabbit hole goes much, much deeper.